Chemcat, your friendly chemistry tutor.
Vapor pressure. Imagine a glass of water. It looks pretty calm, but there's actually particles constantly moving inside of it. Some particles at the surface have enough energy to escape the liquid and become a gas, also known as vapor. This process is called evaporation. Not all particles are successful though. Some lose energy and fall right back into the liquid. This is called condensation. Now here's the key part. The particles that successfully escape don't just disappear into thin air, like the guy who ghosted you. They actually hang out in the space right above the liquid, moving around and pushing upward. This pushing is known as vapor pressure. It basically measures how many particles successfully escape the liquid and are now in the gas phase above it, pushing up. So more escaped particles means more pushing and a higher vapor pressure. Now you might wonder why these particles are still pushing up when they've already escaped the liquid. Shouldn't they be wild and free? Unfortunately, no. On planet Earth, we have something called atmospheric pressure, also known as air. Air acts like an invisible lid on the glass of water. It pushes down while the gas particles push up. Now let's talk about what affects vapor pressure. Number 1, temperature. When we heat this glass of water, the temperature increases, meaning energy is being added to the system in the form of heat, so heat equals energy. As temperature rises, particles are moving faster. More of them have enough energy to escape the liquid, so more gas particles collect on top of the liquid, all pushing upward against air like an army. This causes vapor pressure to increase because vapor equals gas particles above the liquid, and pressure equals pushing up. So again, vapor pressure equals gas particles above the liquid pushing up. When vapor pressure becomes equal to atmospheric pressure, boiling happens. This means a lot of gas particles are pushing up just as hard as air is pushing down. Boiling is a great thing for the gas particles because now they can actually form inside the liquid and survive as bubbles, which are basically pockets of vapor formed inside the liquid that are now able to escape. Vapor pressure is also affected by intramolecular forces. If a liquid has strong intermolecular forces, particles in it are super attracted to each other. It's hard for them to escape because of that strong attraction, so fewer particles become gas. This results in low vapor pressure because only a few particles escape and are pushing above the liquid. On the other hand, if a liquid has weak intramolecular forces, particles aren't held so tightly together, so they escape more easily, and more gas particles form above the liquid, resulting in high vapor pressure. Let's bring cats into this. Some cats love their space, while others are clingy. If we put a bunch of space-loving cats into a small room, they're gonna be pissed. They'll gather at the door and push to get out. The room represents the liquid. The cats represent particles. Cats gathering and pushing at the door represents vapor pressure, and the door pushing back represents atmospheric pressure. If the room gets hotter, the cats get even more pissed. More of them rush the door and push. That's like adding heat to a liquid, because increasing temperature increases vapor pressure. You got it! Here's your knowledge check. Explain why ethanol has a lower vapor pressure than acetone at the same temperature. Pause the video and return when you are ready. Welcome back! When you observe the structure of both ethanol and acetone, you can tell which type of intermolecular interactions they make. Ethanol makes stronger intermolecular interactions compared to acetone, which is why ethanol has a lower vapor pressure than acetone since the molecules are tightly attracted to each other and can't escape that easily into gas. Good job! Thanks for watching. You can find a helpful worksheet on this topic with a full answer key on Chemcat's Payhip and Etsy page. Both are linked in the description below. If you have any questions, feel free to email me at chemcat786@gmail.com. As always, please like and subscribe to support this channel.